Welcome students. Today I am going to discuss CodeVita contest problem part 18. I start with the first problem. The first problem title is Wanderer. I read the problem statement. Nadasa is a country with n cities. These cities are numbered 1 through n and connected by m. Bidirectional nodes. Each city can be reached from every other city using these roads. Initially, Rian is in city 1. At each of the following k seconds, he may move from his current city to adjacent city or stay at his current city. Rian also has q condition a1, b1, a2, b2 up to aq, bq, meaning that during his k second trip, for each valid I, he wants to be in city A after exactly bi seconds. Okay, this is also another constraint. Since you are very good with the direction, Rian asked you to tell him how many different trips could be make while satisfying all conditions. Compute this number modulo 10 power 9 plus 7. Here, the notable point is each city can be reached from every other city using these roads. Okay, so the city represented as n, and m is a edge, number of bidirectional nodes. This this means that it is an undirected graph. Okay, and they have another constraint. At each of the following k seconds, he may move his current city to adjacent city or stay at his current city. And also they have some conditions like a1, b1 and a2, b2 up to aq, bq, meaning that during this k second trip, okay, for each valid I, he wants to be in the city after exactly ba seconds. Here, 3 is a number of test cases. First value, that is second line, first value in the second line is the number of nodes. This is number of edges. This is seconds in terms of k seconds. Okay, here I represent the values. There is which one is connected with which node. One is connected with the 2, one is connected with the 3, and one is connected with the 4. 1, I say 1, 2, 3. One is connected with the 2, one is connected with 3, and we have another node, fourth node. Now one is connected with 4. One is connected with the 2, one is connected with 3, one is connected with 4. Okay. Here, next line, they have given q as 0. 0 means next line will not come. See the another test case. They are given q as 1. So they have one line of statement which represents 2 is a city A and another 2 is a B seconds. Okay. So this is important. Okay. When they give 0 means no input should be received. When they give value as 1 or 2 means you have to get an input accordingly. That is which is a quick conditions. Okay. So here we need to find how many different trips could be made according to the condition. Okay. So this is dynamic programming problem. Okay. By using memorization technique, we can solve this problem. So these are the concerns I have told already. So the number of tricks should be modulated by modulo should be applied if the value is very high. If value is very high, means just you apply modulo 10, that is 10 power 9 plus 7. Here this is the header file, and std using namespace std is used to make use of scene CO statement, and vector which is used to show the set of values of integer type. Here DP array is used for memorization, storing the data, previous values, and SPN mean for maintaining the second values. Okay, user is inputting some values, no, k seconds, no, that value is recorded in the SP array. Here this value, k value. Okay, and for applying modulo to the large values, we use add function accepts to argument, and if a plus b greater than or equal to mod means just return a plus b minus mod, just separate it. Okay, if it exceeds means, otherwise return a plus b, simply just return a plus b. Okay, so every time you perform that is you are counting the number of different number of trips that should meet all conditions. Okay, that is why I have used don't use mod function, just separate it. If a greater than b means just separate by mod or value. Okay, so mod or value may be 10 to the power 9, 10 to the power 9 plus 7. This would be if the number exists 10 to the power 9 plus 7 means separate it. That's all. Don't apply my percentage symbol and all, which is very costly when compared to this operation. Okay, so here I use scene statement for receiving number of test cases, and every test case you have to get n number of nodes and number of edge and k seconds. So first clear the vertex, that is a v list v and dp array to 0. Here sp I already told, no, sp is there is a k value, this is k seconds value. Here I recall it, each of the following k seconds, he may move from his current city to an adjacent city. Or say in the same city. Every seconds he try to move to the other adjacent city, or adjacent city means the node which is connected to the other node. So adjacent for 1 is 2, 3 and 4. So they take 3 seconds for being in the same city or adjacent city. Okay, we have each of the following k seconds. So for the purpose I just maintain SP array. Okay, initially it was 0. I need to maintain SP array also 0 or 0 to k seconds. 0, 1, 2, 3. Okay, just maintain 0. Okay, next I receive m input. Here m for sample test case, here m equals 0, no, this loop will never work. Okay, this loop will never work because m equals 0. If m greater than 0 means I will receive a and b. A and b represents a represents city and b represents seconds. Okay, for each valid I, he wants to be in city A after b second, like that. So that information is stored in the so this is not this is source destination vector. Sorry, here in this loop only when q equal to 0, no input will be received. Here they will receive which one node, which node connected with which node. Okay, for example, they give input like 1, 2, 1, 3 and 1, 4. Means so vector of 1 as the value 2. When you give 1, 2 means vector of 1 contains 2. Okay. When you give 3 means same value. Vector of 2 contains, vector of 1 contains another value. And vector for third input, vector of 1 contains another value. Like this we can give. In a similar way, since this is undirected graph, In V of B also we are pushing the value 1. So V of 2 contains value 1. Then since it is a bidirectional graph, so V of 3 contains value 2. No, 1. Then V of 4 contains the value 1. Okay, so you record vertex information, edge information by using the vector. Okay, next here only I am getting this value Q. Here in this sample example Q is 0, so no input will be received. If Q is 1 means we will receive a pair of values. Okay, so here for the example, here Q equal to 0, consider Q equal to 0 means this loop will never work. So SP of 0 will be recorded as 1. Initially S of 0, SP of 0 equal will be recorded as 1. After that, we just accordingly just set dp of yes, the value source vectors may be available in the source itself. So dp of 1 equal to 1. Okay. Next, if there is we are starting with 1 to k, and you need to check every vertex which is connected with every other vertex, no, by according to the condition. You have edge information in the B, so we need to check for all the vertices. That is for k seconds. For k seconds, here they given k equal to 3. Okay, for k equal to 1 second, we need to get the input. Okay, how many trips are passed? K equal to 2 also we need to check. K equal to 3 also we need to check. Totally, when k equal to 3 means we need to check the trips. Now, how many check? We need to count how many number of trips are possible for k equal to 1, for k equal to 2, for k equal to 3. That is why I have given this. And inside the loop, we need to explore the edge detail. Okay, so edge detail is available in this array here. Okay, so first you have to take V of 1. That is why I have V of 1. You have to take V of 1. That is why you have used V I j equal to 1, j less than or equal to n, j plus plus. This is number of vertices. First take first vertex information, that is edge information. V1 is connected with the 2, 3, 4. No, just explore it. Just temp of j initially 0. So add of temp of j already 0. So dp of j already 1. So in temp of j we record 1. Next we record 1. Then immediately we need to connect for source. From source we have we make a trip. No, say the the node may be available in the same node. Maybe make a trip in same place itself. So that is that value is recorded here, and we need to associate with the other adjacent nodes also. For example, here 1 to 2, 1 to 3, 1 to 4. There are 3 nodes connected with 1 node. That is also accounted. For the purpose, I just use auto. This is iterations, for loop, which is used to explore what are the nodes which is connected with the source node 1. So that is also recorded. So it makes a trip, no? 3 trips. One is connected with the 2, and there is a 1 trip. One is connected with the 2 is another 1 trip. One is connected with the 3 is another trip. So total 3 trips are made. No? That is also recorded here. Okay. In a similar way, all the trips are recorded. Okay. Next, if SP of I is true means, for example, SP of I, here SP of 0 is 1. Okay. So we set SP of 0 equal to 1. So other values are 0. Okay. So it does not has condition, different conditions. Okay. After every seconds, it makes a trips. Here we have in sample input we have only 0, so it does not have other conditions, few conditions. Okay, it has nothing. So just to check whether SVF I equal to 1. So here I equal to I equal to 1. So SPF 0 only 1. Okay. So SPF 1 we are not having any values. Okay. So this condition will not work. Okay. SPF 0 equal to 0 only. So this condition will not work. So it goes else part. In else part we have recorded the number of trips in the temporary, that is stored in the DP array. Finally, we print the DP array by adding the answer. Okay. So in DP array, we just adding the answer with the DP array. So consider all the trips from source to other destinations are accumulated by using the answer. Okay. Here, suppose SP of 0, SP of 1 equal to, for example, SP of 1 equal to 1 means this condition will hold. Will go to the loop. Here, just check all the nodes and whether we are having the values at every seconds we are trying to move some other nodes or not. We just check. If it is so, it will just record dpfij equal to 10. It does not mean just set the dpfj equal to 0. Okay. So finally we are adding the result which is available in the DP array. DP array contains values which holds the values of how many trips are made from source to the particular destination. For example, DP of 1 holds there are information about the how many trips we made from source to destination. From source 1 to the destination. DP of 2 holds how many trips we made from 2 to other destination. DP of 3 holds how many trips we made from 3 to other destinations. So these informations are accumulated to get the result, which is an answer. This is complex problem. Okay, start to read a second problem. Problem title is different ways. The problem, I read the problem statement. Given two natural numbers n and m, the task is to find a number of ways in which the numbers are greater than or equal to m. Okay, the task is to find the number of ways, how many number of ways in which the number that are greater than or equal to m, okay, can be added to get the sum n. Okay, here n equal to 3, for example, m equal to 1, the output will be m, output will be 3. So to get sum 3, sum 3, we will add 1 plus 1 plus 1. There is one possibility. Okay, this is greater than or equal to m only. So we take 1 and 2. That is another option to get result 3, and we have only one option 3. There are 3 possibilities now, so the answer will be 3. Okay, so we need to find the number of ways which the number which is greater than or equal to m can be formed, greater than or equal to m, to get the sum m. Okay, to get the sum n. So we need to attain the value n, and which should be greater than or equal to m. Okay. And also we need to find the number of ways. What are the number of ways? So this problem can be solved by using dynamic programming. Okay. So dynamic programming makes use of memorization concept. Okay. First we need to find, to get sum n, how many number of ways to get value. For example, to get sum 3, how many number of ways are possible by using the 3. Okay, to get sum 3, and next to get sum 3, how many number of possibilities are available by using the 1 and 2. That is also accounted, that is stored in the memory. And to get 3, Next step, to get 3, how many number of possibilities are available? To get sum 3, how many number of possibilities are available by using the 1? Okay, so these are the values are recorded by using the DP. For example, here I account the number of ways. Here n is the sum, and we need to select the value which is greater than m. Okay, they give value as 3 here, value as 1. So we need to select the value. Again, we need to select the value which is greater than or equal to 1, and we need to attain something. So this is the DP array. The DP array holds previous, that is past informations. Initially it was set as 0. Okay, here in DP array we have 2 dimensions. Okay, we record the information by using the loop. Here k represents the numbers. Okay, what are the numbers you take for getting the sum 3? Okay, that is k is for number, that is outer loop is for numbers and inner loop is for sum. Okay, so we need to initialize the number of ways to get a sum using numbers greater than or equal to k plus 1. Okay, I start here, consider n equal to 3. I start with k equal to 3. Okay, which is checking for which will be compared with the m. Consider m equal to 1. So condition is true, no? So it will go for inner loop. In inner loop, I start with 0. For getting 0, the solution will be available. Okay, so that is recorded here. For dp of 0 of that is k plus 1, that is 4. 0 of 4 will be stored. Okay, 0 of 4 already we have 0 only, so that is recorded here. Okay. And if I greater than I minus k greater than or equal to 0 means, for here in I equal to 3. Okay, k equal to 0. 3 greater than or equal to 0, no? So this condition will work. In this condition, I just take previous information. For example, dp of I minus k, g, I minus k of k. Okay, so this information is accumulated to get the result. Okay, so initially dp of 0 of n plus 1 will have the value 1. Why means for getting the value n plus 1 value, for getting the n plus 1 value, we use 0. The solution will be available. Okay, so because k value is greater than 0 only, so the solution available, so we will store the value as 1. Okay, so dp of 0 of n plus 1 has the value 1. So row is for this information is for numbers. Okay. So without selecting itself, we can get the result. So value is 1. That by using this information only, we are accumulating it. Okay, I just run the statement. You get to know about these. When I give 3 and 1, so I need to attain a sum 3, and by using the value which is greater than 1. So here just watch first column, that is dp of this one. If you have 0 plus n plus 1 contains a value 1. This is 1. By using this only, we are recording it. Okay. So k is for numbers. This is for k. There is number set of rows. Rows will be called. Will be recording the information about the number. Column is for sum. For getting 0, for getting 0, the solution available. Only one possibility is. Okay. For getting 1, for getting 2, for getting 3. For getting 3, we have 3. This information is printed here, so I get the result 3. Okay, so please remember that row is for numbers. For example, if I take value 1 means there is only one solution available in this which is recorded here. Okay, if I take 2 means, okay, so I need to attain a solution 3 now. By using the number 2, I can get only one solution, which is already available. Okay, only one possibility. So by using 2, I can't get 3 as a result, because 2 is a even number and 3 is a odd number. I can't able to get 3 by using 2. So already recorded information available in the same location. There is a recorded information 1 is available in this location. For getting 3, I can make use of 1. Okay, so for the first that information is available here. Okay, so for getting 3, I can use 3 itself. Okay, that information is available here. For getting 3, I can make use of 1. That information is available here. So for getting 3, I can make use of 1 and 2 to get 3. That information is available here. So this is row, this column. Okay. This row represent for numbers. This column represent for sum. For getting 3, we can have different possibilities. For example, 1 plus 1 plus 1, that is one possibility. 1 plus 2 is another possibility, and 3 is another possibility. 1 plus 1 plus 1, one possibility. 1 plus 2 is another possibility, and 3 itself is another possibility. Okay, so this is one. This information represents we can get 3 by using 1 plus 1 plus 1. This information is called stored here. So we can get 3 by using 1 plus 1 plus 1 is another solution, and along with that we have 1 plus 2, that is second solutions available, 2 solutions available. We can get 3 by using 1 plus 1 plus 1 and 1 plus 2 and 3 itself, that is third solution which is available here. Okay, so these information are recorded in the DP array. This makes sure that if I minus greater than or equal to 0 means just we need to subtract it. Okay. Subtract I minus k and pass it to the array. Okay. So we meet in the next class. Thank you.